Today we're going to talk about relations, domain, and range. So we're going to go through and fill in our notes, but don't forget to go back and come up with your essential question and your questions here while you're answering. Okay? So, a relation is a set of ordered pairs. Now we can express relations in 4 different ways, so let's list those. One is just listing the ordered pairs. A second way is to list those ordered pairs in a table. We can show those ordered pairs in a mapping, or we can plot the ordered pairs on a graph. Now mapping may be new to you, the others you should recognize. So in example 1, we have a graph that's given to us, and there are points on there. So we're going to answer the 3 parts. The first part asks us to list the set of ordered pairs. So when you read a graph, you read from left to right. So we're going to start farthest with the point farthest to the left, and that is this point here. So from the origin, we count left 1, 2, 3, 4, 5, and up 1. So that first ordered pair is -5, +1. Here's the second ordered pair. We're going to go left 3 and down 2. So that ordered pair is -3, -2. Our third point is left 2, down 1, 2, 3, 4, 5. So left 2, down 5, -2, -5. Then we have a point at the origin, which is 0, 0. Our next point is 2 to the right and 2 up. So +2, +2. Our next point is 4 to the right and 1, 2, 3, 4, 5, 6 up. So 4, 6. And our last point is 1, 2, 3, 4, 5 to the right, down 2. So 5, -2. Now when we have a set of ordered pairs, set notation has the braces wrapped around the ends of our list. Alright, B asks us to put the ordered pairs in a table, and when we put them in a table, we keep them paired together. So I'm just going to list them in the order that we wrote in part A. So -5, 1, -3, -2, -2, -5, 0, 0, 2, 2, 4, 6, and 5, -2. So when you read a table, the points are paired together. But for C, this is a mapping, and this is new to you. We're going to list our x coordinates in order from smallest to largest inside this oval for x, and we're not going to repeat any if they happen to repeat. If we use our table, our x coordinates are already listed from least to greatest because we read our graph that way, started with the lowest x and moved to the highest x. So I'm just going to recopy. -5, -3, -2, 0, 2, 4, and 5. Now for the y's, those are not listed in numerical order from least to greatest. So I'm going to rearrange them to put them in the oval. And again, we're not going to repeat any numbers if they happen to repeat. So looking at our list, -5 is the smallest number. Then we have 2, -2, so I'm only going to write it once. From there we have 0, we have 1, we have 2, and +6. Okay. Now, to show which x goes with which y, we're going to draw an arrow to connect them. So -5, 1 is 1 point. So we're going to draw an arrow from the -5 in the x bubble to the +1 in the y bubble. And we did the same, -3 to -2, -2 to -5, 0, 0, whoops, kind of missed that one, 2, 2, 4, 6, and then 5, -2 comes back up here. So you just follow the arrows when you are reading a mapping. Now, our domain is our set of all first coordinates. And your first coordinates in your ordered pairs represent your x coordinates. So this is just a list of all of your x's. So in example 1, our domain would be all of our x coordinates, either from the ordered pairs, from our table, or from our mapping. And usually when you list your domain, you list it in order from least to greatest, and you don't repeat the numbers again. So I say usually because sometimes you might see them not in order from least to greatest. They may be random. They may be from greatest to least. And again, it is a set of ordered pairs, so we use the set notation with the little wavy braces. If your domain is your set of all x coordinates, then your range will be the set of all your y coordinates, or second coordinates in your relation. So this is just a list of all of your y's. So our range, again, we want to make sure that it's in order from least to greatest and not repeat anything, so we can still use the ordered pairs or the table, but if we use our mapping, it's already in the right order for us, and we've taken out the repetition. So we have -5, -2, 0, 1, 2, and 6. Okay, as we continue, we have a word here and a definition that we've already discussed, a function. And we know that a function is a relation in which none of the first coordinates repeat. Notice it is a relation, but it's a special relation. And since none of the first coordinates repeat, that means that all of the x's are different. So we're going to go through some examples, and we're going to state the domain and range and then determine if we have a function. And we can determine that from a set of ordered pairs, from a table, from a mapping, from a graph. All right, so if we look at example 2, the domain are our x values. And so all of our x values are the first numbers in our ordered pairs. So if we put these in order from least to greatest, -1 is the smallest. Then we have 2, 3, and 6. Our range are all of our y values, and the y values are the second numbers in your ordered pairs. And again, if we put them in order from least to greatest, 3 is our lowest number, 4, and then we have 2 5s, but we're only going to write it once. So, do we have a function? Look at your x's. Do any of them repeat? All of them are different, so yes, this is a function. No x's repeat. And it's always good to put the reason why you say it is or isn't a function. Example number 3, again, we have a set of ordered pairs. Our domain will list our x values. We have 1, -2, 1, -4, and 2. So -4 is our smallest, then -2. We have 1 twice, but we're only going to list it once, and then we have 2. The range, we're going to list our y values. We have 9, 5, 6, -3, and 8. So -3 is our smallest. Then we have 5, 6, 8, and 9. So now, is this one a function? Does example 3 represent a function? And if we look back at our x values, we have 2 number 1s, 2 1s, so no, x repeats. We have 2 x coordinates equal to 1. In example 4, we are asked to take the relation that's shown here in the mapping, list it as a set of ordered pairs, identify the domain and range, and then again determine if it is a function. So our ordered pairs, notice this mapping goes from greatest to least on both sides, which is fine. So we have a set, so open your set notation, and we're just going to start from the top and we're going to follow the arrows. So we have 2, 12, we have 2, -3, we have 1, 5, we have 0, 0, and we have -1, 5. Our domain will be all of our x values, 2, 1, 0, negative 1, or you could start from the bottom and put them smallest to largest. Our range, 12, 5, 0, and negative 3. And is this a function? And the answer is no. When we listed the ordered pairs, we saw that 2, the x value of 2, occurred twice. You can also see from your mapping you have 2 arrows that come off of the x value of 2. Okay. So make sure that you go back and you highlight, you underline, you study your notes, come up with your questions and your summary. Okay.